Factors affecting pressure in liquids. Factors affecting pressure in liquids can always be investigated by using a funnel connected to a U-tube and dipped into a beaker of water. It is observed that the deeper the funnel goes, in the water in the beaker, the greater the difference in the height in the U-tube connected to the other end of the funnel. Also, the same experiment can be used to show variation with density, and in that case, a different liquid is used and observations are made. The observation made in such cases is that the height h obtained for the first case is different from the second h obtained. So if this one is h1, then h2, when a different liquid is used, is different from h1 for the same depth of the funnel into the beaker. Depending on the density. From these observations, we make the following observations and conclusions. 1. Pressure in a liquid increases with depth. Pressure increases with depth. And therefore, depth is one of the factors affecting pressure in liquids. Pressure in a liquid at a particular depth is the same in all directions. Pressure at the same depth is the same in all directions. Then number 3, pressure increases with the density of the liquid. With the density. Let's now look at the fluid pressure formula. So in this case, we consider a cylinder which is filled with the liquid to the height h shown in the diagram. The cylinder has a weight and therefore exerts some pressure on the surface. If A is the cross-sectional area and h is the height and the density is given as rho, then the volume of the liquid is equal to the cross-sectional area multiplied by the height. So V equal to A times height. The mass of the liquid is given by the volume multiplied by the density. So mass is V times rho. V is already A times H. So if we substitute this into this, we have A H multiplied by rho as the mass. Therefore, since weight is equals to mg, then we substitute m into this so that we have A H rho g as the weight. From the definition of pressure, pressure is equals to force over area. Force is in this case given by the weight. So we have pressure equal to the weight over area, which is equals to A H rho g divided by A. We note that A's cancel out, and therefore pressure due to the liquid column H is given by H rho g. H is the height, rho is the density, and g is the gravitational force per unit mass. From this, pressure is proportional to the height of the column H and the density rho of the liquid, and does not depend on the cross-sectional area of the container.